Have you ever contemplated why some mathematical problems seem easier to tackle in one domain than another? It's a fascinating thought, isn't it? This is the magic of domain transformation. In the world of mathematics, some problems are simply too unwieldy and require an immense amount of computational power to solve in their original domain. However, when we shift these problems into a different domain, certain characteristic features come to light, simplifying the solution process. Take linear order differential equations, for instance. Trying to solve these in their differential domain can be a strenuous and time-consuming task. But by transforming these equations into the Laplacian domain, we uncover a specific characteristic feature that aids us in finding their solution. The same principle applies when identifying the frequency of a signal. This task becomes significantly easier in the Fourier domain, a subset of the Laplacian domain. Similarly, identifying a control system's impulse response also becomes more straightforward in the Laplacian domain. Domain transformation isn't restricted to these examples. Whether it involves principal component analysis, spectral graph theory, or even a task in machine learning, we often find ourselves transforming from one domain to another to solve the problem more efficiently. So how does this transformation happen? We need a transformation operation or operator that maps the problem from one domain to another. This operator is known as the eigenoperator. Now, what exactly is an eigenoperator? It comprises eigenfunctions in continuous transformation and eigenvectors in discrete transformation. The beauty of the eigenoperators is that they remain unchanged upon transformation. This makes them an ideal basis for transformation. The term eigen is German for characteristics. Therefore, an eigenoperator is essentially a basic set of characteristic features represented by vectors or functions. We use this set to map the problem from the problem domain to the eigendomain. This mapping reveals the problem's identity and simplifies the solution. For instance, when we solve linear differential equations using Green's function, we obtain the eigenfunction for a specific type of differential equation. This eigenfunction is then used for the eigenoperation. To illustrate, let's consider a few everyday examples. Suppose to navigate your way through an unfamiliar city without a map. This city represents the problem domain, and it's like a maze with countless twists and turns. The process of transformation is akin to switching on a GPS. Suddenly, the city's layout becomes clear and navigating becomes a breeze. This is the power of the eigendomain. Or envision you're attempting to translate an ancient cryptic language into English. The problem domain comprises the incomprehensible language and its intricate symbols. When processed with an eigenoperator, these symbols are transformed into simple, understandable English, revealing the problem's true identity and making the solution evident. Let's add another example to this. Suppose you are an ageless being that existed before everything and will be there after everything unchanged. You are essentially an eigenfunction for the rest of the time-dependent entities. You would be able to map all of the temporal events and reveal their temporal characteristics. This is how you, an ageless entity, could serve as an eigenoperator, making the complexities of time much more comprehensible. These are the remarkable properties of eigenoperators in real-world scenarios. In essence, domain transformation and eigenoperators are key to simplifying complex mathematical problems. This shift in perspective from one domain to another allows us to uncover characteristic features that streamline the problem-solving process. It's truly a testament to the beauty and versatility of mathematics. Now, just the tip of the iceberg, there's much more to domain transformation and eigenoperators than meets the eye. So stick around as we delve deeper into these fascinating concepts in the next section of the video. In an interesting twist, let's draw a parallel between the world of mathematics and spirituality. Imagine for a moment that we're not just students of mathematics, but also seekers on a spiritual journey. Our spiritual master, Sri Ashutosh Maharaj Ji, through DJJS, SAM, and various other initiatives, introduces us to a concept akin to our mathematical eigenfunctions, Brahmgyan. Just as eigenfunctions remain stable during transformations, revealing the core characteristics of a problem, Brahmgyan remains a constant, a pivotal point between the physical and spiritual worlds. It reveals our true nature, our inherent characteristics, making it easier for us to assess ourselves and manage our life issues effectively. Now, the challenge lies in finding the eigenoperator. In mathematics, we don't have to reinvent the wheel. We don't have to rediscover the works of Dirac, Laplace, Fourier, or Green to solve problems. Similarly, in our spiritual journey, finding the spiritual equivalent of an Eigenoperator or Brahmgyan is like reinventing the wheel. But thankfully, our Guruji has it and is ready to share it with us. Our part of the journey, much like in mathematics, is to apply these teachings to our lives, to meditate, and to transform ourselves using this spiritual Eigenoperator. Just as domain transformations filter out noise and undesired frequencies in mathematical problems, meditation with Brahmgyan helps us control our thoughts, identify our true characteristics, and become more focused and resolved individuals. Let's explore this in more detail in our next segment. In our journey through mathematics and spirituality, we're often faced with concepts that are complex, challenging, and sometimes seemingly incomprehensible. We might not always have the expertise to evaluate the work of a mathematical genius or a spiritual master. But just as a high school student can understand the essence of scientific discoveries through simplified parameters, we too can gauge the authenticity of spiritual teachings. Imagine for a moment you're in a classroom learning about the groundbreaking work of renowned scientists like Dirac, Laplace, Fourier, or Green. You might not fully comprehend the depth of their theories, but you understand the basic principles. You can appreciate the impact of their work, and it inspires you to delve deeper into the subject. Now let's apply this analogy to the spiritual realm. Not everyone can claim to be a true spiritual master, but we can still gauge the authenticity of their teachings. Just as we can't see radio waves with our naked eyes, we often can't perceive the depth of spiritual wisdom without the right tools. But does that mean we deny its existence? Of course not. We use radio telescopes to see radio waves, and similarly, we use meditation and the teachings of our spiritual master to perceive the spiritual truths. However, there's a pitfall we must avoid. We often expect to master spirituality in an exponentially shorter period than we would for an academic subject. This expectation is flawed. Just as we can't claim mastery over riding a bicycle by merely reading, studying, and writing a thesis about it without actually riding it, we can't claim spiritual enlightenment without practicing and experiencing it. The true mastery of spirituality, like mathematics, comes with understanding, practice, and experience. So let's not rush our journey. Let's take our time, learn, practice, and grow at our own pace. To learn more, log on to djjs.org.